Hello everyone. So let's start today's lessons. So the first thing we are going to do is we will revise a bit of what we did last day. So to give you a quick recap, we first discussed what was dynamic programming. We discussed about the approach, like the stages of dynamic programming solution. First we think of a recursive solution, then we memorize it, then we try to do memorization of the solution, and followed by that we also try to do tabulation. So after that we discussed some problems, and we started with the most important problem, with the first problem called knapsack, which is a pretty important problem. We discussed the types of knapsack problems, and then we started with the 0-1 knapsack. So the first thing we did was we tried to create a recursive solution. We tried to understand the intuition behind recursion, and like we created a decision tree to create the recursive function. And after we created the recursive function, we improved on that using memorization. And once we did that, we got a dynamic solution. Memorization is basically a dynamic programming solution. So once we got the dynamic programming solution, we further improved the solution using tabulation, which is a bottom-up approach, and we formally created the code. So this is all that was done last day. So today the first thing we are going to do is we will discuss a few problems related to knapsack. Like they are closely related to the knapsack approach, and like more or less all of these problems can be solved using the same approach as we used in knapsack. So the first problem we will be discussing today is subset sum problem. So what is the subset sum problem? This is a very common dynamic programming problem. So subset sum problem states that given a particular sum, we need to find the subset in the given array such that it adds up to the given sum. So what does this mean? For example, we are given a set of array elements called 3, 34, 4, 12, 5, 2, and we are also provided with a sum. So we need to find a subset within this set such that on addition of the subset elements, we get this particular sum, and we need to return true or false. Like over here, when sum is equals to 9, we can form a subset such that using 3, 4 and 2, so that 3 plus 4 plus 2 is equals to 9. We can also create another subset called 5 plus 4, which will also give us 9. But let's say in case we are given sum is equals to 1, like this is not practically possible to create a subset on addition of on addition of the elements of the subset. We can never get 1, so this will return false. So we are clear till here, right? So and how is this similar to knapsack? See, what happened was in knapsack we were given a sack and we were told to fill it with the weights of the elements, right? Over here this is more or less the same approach, where we are given a sum and we need to like match the sum level using the elements from the set, right? So the approach will be same. If an array element is greater than the value of the sum, it cannot be added, and for every other element we have a choice of adding it or we can also reject it, right? So you see the approach is more or less same, but what is the big difference? In knapsack we had a value array, we kept on adding the value in the matrix, in the dynamic programming matrix, tabulation matrix. But over here we don't need that. What we need is just true or false. Like, is it possible to create a sum of subset? Like, given a particular sum, is it possible or is it not? Like, we just need to return our answer in binary. So like if we try to create some analogy between knapsack and this particular problem, we see that this set value, like the array provided, is pretty similar to the weight array we were provided earlier, and the sum is pretty analogous to the sack, the capacity that was provided to us earlier in knapsack. So let's say we try to create a matrix, okay, and we consider, like over here we put the sum, all the elements sum plus till sum plus 1, and all the array elements over here, n is this side and sum plus 1 is this side. So what we do is, let's assume that we create this matrix, and where each element, like let's say this element, what does this mean? This means, like, if we get 1 over here, if we get 1, this means when we are considering the first 4 elements, there is a possibility, like when we are considering the first 4 elements, there can be a subset which will add up to 5. And if we get 0 over here, what does that mean? If we are considering the first 4 elements, there cannot be a subset which will add up to 5. So let's see in this case what happens. If we consider the first 4 elements, 1, 2, 3, 4, is it possible to create a subset whose sum is 5? No, it's not. So here we will get 0, despite the fact we have an element 5. So that is how we will create the subset, right? So let's think about the base cases. What will be the base case? So when we don't have any elements in the array, is it possible to create a sum? No, it's not. So this will be 0, 0, 0, 0, 0, 0, 0. Right? This is pretty intuitive. And given that we have like the sum, we are required to create a sum of 0, and we are given any number of array elements. Yes, we can always create a sum of 0 using empty subset, right? Empty array is also a subset. So this will be 1, 1, 1, 1, 1, 1, 1. Now, yeah, just like I was saying, so the base case is, like I said earlier, the base case is the minimum valid input. So when w is equals to 0, we can get empty subset for sum is equals to 0. So this will be true, 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 or 1, 1, 1. And n is equals to 0, there can be no elements available to generate any given sum of value. So this will be false, false, false. Cool. So these are the codes for the base cases. So we are clear until now. Now comes the main approach of filling up these elements. So let's think about it. When we are trying to enter this element, enter the value of this element, what will we look at? Like, let us think of Knapsack and try to create an analogy over here. So dp of I, j, if this particular element, like arr I minus 1, the value of this particular element, if this is greater than the sum we are dealing with right now, j, if this is greater than j, is it possible to add this sum? Like, is it possible to add this value to the to get a sum equal to this? No, it's not. So in that case, dp of I, j will be dp of I minus 1. So whatever it was using, considering the last 2 elements, and j using the same weight. So let me give you a better analogy over here. So now for the rest of the elements, we use the top down, like rest of the top down code, the approach will be very similar to that of Knapsack. So for each item, if the item is greater than is equals to sum, we can choose to add that element, or we can choose not to add that element. And in case if that element is greater than sum, we choose, like, we cannot add that element, like I was saying last. So we have already created the base cases. Now we start with I is equals to 1 to I less than is equals to n, I plus plus, j is equals to 1, j less than is equals to sum, j plus plus. So I denotes our n, j denotes our sum. Cool. Now if the array element is less than equals to the sum that we are considering at that particular moment, yeah, this is okay. So we can choose to add that element, or we can choose not to add that element. If you remember, in case of Knapsack, what we were doing is we were trying to find the max of both these cases. Yeah, so since we were considering like the maximum possible value that we can get in the sack, right? But that is not the case over here. Over here we are saying, is it possible to create a sum or is it not, right? Is it possible to create a subset sum of the given sum value, of the given j value, or it is not possible? So what we will do is dp I minus 1 comma j. What does dp I minus 1 comma j denotes? dp I minus 1 comma j denotes we are not considering this element, we are not adding it to the current sum value, Okay, and what does dp I minus 1 and j minus arr I minus 1 denotes? That dp I minus 1 j minus arr I minus 1 denotes that like we are considering this element. Cool. So we are considering the sum of this element, and like these are both the cases. So when we are considering this element, the remaining sum is getting reduced by arr I minus 1. I minus 1 is because of the indexing, like I explained earlier, and this is because of this one when we are not considering that particular element. This will just copy the earlier case. So when we do an OR of these two cases, we get if this is possible or this is not. If it is possible, like if we can get a sum value of j in either of the two cases, it should be possible, because like if this case is possible, if we add arr I minus 1, we will get this one. So this will be an OR of both the cases. Like in case of max, in case of knapsack, this is replaced by an OR. Cool. And the rest of it is like exactly similar. I don't think there is any need to explain. So to give you a like bit of summary of what we did right now, so we were supposed to create a subset sum. Okay, like we are supposed to create a subset sum such that the sum value matches the given sum that we are provided. So what we are doing is we are telling, like we are creating a matrix where there are only two values, 1 and 0. So 1 denotes, 1 for any particular item denotes that using these many array elements, it is possible to create a sum of this one. So like for over here it is possible to create a sum of 3 using the first two elements of the array. What does this mean? This means using the first 4 elements of the array, it is not possible to create a sum of 4. What does this mean? This means using the first 2 elements of the array, it is possible to create a sum of 7. So after that, what we are doing? What we are doing is we are choosing to add the element, or we are choosing to not add the element. Like if the item is greater than the sum, it is not possible under any circumstances. But if the item we are considering is less than equals to the current sum we are dealing with, remember the word current sum, because you know j is varying from 1 to some. So in that case, we will consider the case when we are not considering that element, or we are not adding it to the sum, dp I minus 1 comma j, and another case when we are considering the sum, so dp I minus 1 j minus arr I minus 1.